guys, Miss Miklos here, and today this lecture is going to be a little bit longer because we are combining two concepts in one. So today we're talking about the quadratic formula, which is something that you guys actually learned back in Algebra 1. And here's our equation for the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And a, b, and c come from the coefficients of our quadratic function. So notice this is in descending order, our x squared term, then our x term, and then our constant. It is also set equal to 0. The second concept that we're talking about today is what we call the discriminant. Okay, our discriminant is b squared minus 4ac, and in this lecture, we are going to kind of discover on our own what the discriminant tells us and why that is important. So in our examples today, we are going to find the zeros using the quadratic formula. Then we are going to sketch a graph of the solutions, and we haven't really learned how to do that yet, so we are going to be using an app today called Quick Graph. So you may want to go ahead and watch this on your computer or something so that way you can kind of use this app to help you out. We will also be using this app in our next lecture, so it might be a good idea just to have that on hand. Then lastly, we are going to evaluate the discriminant. So there's really three things that we're doing in each problem. Example number 1 is y equals x squared minus 9x plus 8. Since we are finding the zeros, the first thing I'm going to do is take this equation and set it equal to 0. Remember that the reason why we call x-intercepts zeros is because our y value is actually 0. So if I'm going through this, I need to figure out what is my a value, what is my b value, and what is my c value. I know our a value is the coefficient of x squared, which in this case is 1. Our b value is the coefficient of x, which is negative 9. And our c value is whatever the constant is, so that is 8. So here is the quadratic equation, and what we're going to do now is just substitute stuff in. So I know that the opposite of negative 9 is just 9. Then I have negative 9 squared minus 4 times 1 times 8 over 2 times 1. So as soon as I determine what a, b, and c are, this simple part about the quadratic equation is I'm just simply substituting things in for those three variables. Now we're going to go ahead and actually evaluate this expression. So I get 9 plus or minus the square root of 81 minus 32 over 2, which becomes 9 plus or minus the square root of 49 over 2, or 9 plus or minus 7 over 2. Now, I know this is not my final answer because we can simplify this further. So I have to do 9 plus 7 divided by 2, and I also need to think about 9 minus 7 divided by 2. So I end up getting 8, and I end up getting 1. So these are our two answers. Now, some things that I know that these two values are going to show up on our graph. And I'm just going to go ahead and quickly sketch this graph for us. So here's a picture of this graph, and I just want to point out that it does cross the x-intercept at 1 and at 8. So that confirms that we did get the correct x values when we were solving for when y was equal to 0. The final thing we need to do is find the value of the discriminant, b squared minus 4ac. And that actually should not take us very long to do because b squared minus 4ac is what is underneath the square root. So if we look back at our original work, we see that our answer should be 49. Okay, so let's go ahead and do the same thing to problem number 2. So the first thing I'm going to do here is go ahead and set this equal to 0. And this particular time, we know that our a value is 2, our b value is negative 17, and our C value is 21. So once again, I'm using this equation that we have memorized. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And all I'm going to do is substitute in. So I know that the opposite of negative 17 is 17. So I have negative 17 squared minus 4 times 2 times 21 over 2 times 2. So I get 17 plus or minus the square root of 289 minus 168 over 4, which becomes 17 plus or minus 121 over 4, and I should say the square root of 121, which becomes 17 plus or minus 11 over 4. Once again, I know that we have two different answers here. I have 17 plus 11 over 4, and I have 17 minus 11 over 4. So I end up getting 28 over 4, which is 7, and I get 6 over 4, which is 3/2. So these are our two answers. Now once again, I'm going to go ahead and sketch a graph. I know that these two values should be our x-intercepts. So this would be the graph of our function. And once again, I notice here that it crosses at 3/2 or 1.5, and it also crosses at 7. So the final thing that we need to do is find our discriminant, which we know is b squared minus 4ac. And if we look back at our problem, we saw that underneath our square root, we had a value of 121. Okay, so for 1 and 2, we saw that both of those functions had two solutions, which makes sense because our degree is 2. We also saw that they were both actually x-intercepts and they crossed the x-axis. So now we're going to go ahead and do 3 in the same exact way. So I've gone ahead and I have already set it equal to 0, and I figured out what all 3 of our values should be. And this time I'm not going to write out the quadratic formula. We'll probably all get to a point where we know it by heart. So I'm going to do the opposite of b plus or minus the square root of b squared minus 4ac over 2a, which simplifies to be 4 plus or minus the square root of 16 minus 52 over 2. When I subtract, I get negative 36, which gives us a problem because we have a square root. However, we know that we can just take an I out, so that becomes 4 plus or minus 6i over 2. When I simplify this, it becomes 2 plus or minus 3i. And one of the biggest mistakes I see on a problem like this is that we forget to divide both of these values by 2. So I need to divide both terms in the binomial, in the numerator here, by the monomial in our denominator. So these are our answers, 2 plus or minus 3i. We do have two answers because I have 2 plus 3i, and I also have 2 minus 3i. So let's look and see what this graph looks like. So when we graph this function, this is what it looks like, and I want us to notice that it actually does not cross the x-axis, which would make sense because both of our answers, our zeros, were both imaginary. So there's no way that we can graph imaginary values. Now we need to find the discriminant, and when we look inside our square root, we ended up getting a value of negative 121. Moving on to number 4, this time it says g of x, but we know g of x just means y. So we're going to go ahead and set it equal to 0. So our a value is 1, our b value is negative 6, and c is equal to 10. So when I substitute this in, the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And I haven't really mentioned this before, but notice that whenever I substitute a value in, I'm using parentheses. Here I didn't because I already simplified that in my head, the opposite of -6. Where it becomes really important is when I square -6, because this is telling me that I'm taking -6 squared rather than the opposite of 6 squared. So parentheses become extremely important. So this becomes 6 plus or minus the square root of 36 minus 40 divided by 2, which simplifies to be the square root of -4, which we know is 2i. So when I divide both of these by 2, I get 3 plus or minus I. Once again, I have two answers, which makes sense because we said a quadratic function will always have two solutions because our degree is 2. So let's go ahead and graph this now. So here's the graph of this function, and once again we notice that it does not cross the x-axis. Now let's go ahead and determine what our discriminant actually is. If we look back at our problem, underneath the square root we had a value of -4, so our discriminant here is -4. Moving on here to number 5, we're going to start by setting this equal to 0. And what we've been seeing is that for all of these functions, and really for any quadratic function, using the quadratic formula always works. So we've really learned 4 methods so far. We've learned factoring and finding radicals, which those are the 2 easiest methods, however they do not work for every single quadratic function. Our other 2 methods are completing the square and the quadratic formula, and those both work for any quadratic function that we see. So let's actually apply the quadratic formula here. So I would do the opposite of b, plus or minus the square root of b squared minus 4ac divided by 2a. And something really strange happens here because I end up getting 0 in our square root. So I end up getting 6 plus or minus 0 over 2, which would be like 6 plus 0 over 2 and 6 minus 0 over 2. So I actually get the answer of 3 both times. Now if you just wrote 3 once, that would be completely fine, okay? But I just want to stress that the quadratic function does have 2 answers, and we're going to see something special happen in our graph. And we talked about this a little bit at the beginning of this chapter, where when I get the same answer twice, we call that a double zero, and it actually bounces off of the x-axis. So let's go ahead and graph this. So if we take a look at this, we notice that at an x value of 3, it literally bounces off the x-axis, okay? It doesn't pass through. It's like it's a floor, and it hits it, and it's a bouncy ball, and it bounces straight up. This is a unique function of a double zero. We only see this bounce if I have an answer more than once. So now if we look at our discriminant, our value inside the square root was 0. So 0 is the value of our discriminant. Last full problem we're going to do here. And yes, it looks rough because we have that fraction, but that's okay. So I have x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And once again, something strange happens on this problem because I get the square root of 1 minus 1 over 2, which gives me -1 plus or minus the square root of 0 over 2. So our answer is -1/2. And once again, I could write that once or I could write it twice. Either way, we know that this is a double zero and it's going to have an impact on our graph. So here is the graph of that function, and once again we notice at -1/2, it does indeed bounce off of the x-axis. When we try and find the discriminant, we find once again that our discriminant this time was 0 because there was a 0 underneath our square root. Okay, so how the heck does the discriminant connect to our graph? And that's what we're going to figure out right now. So when the discriminant was positive, and that was like problems 1 and 2, we found 2 solutions, 2 x-intercepts, and both of those solutions were real. When the discriminant was negative, like 3 and 4, if we look back, we saw that we had 2 solutions, but this time we had no x-intercepts. It never crossed the x-axis because our answers were actually imaginary. Lastly, when the discriminant value was 0, and that was like 5 and 6, we only found that there was 1 0 because that was when we had a double 0. So we had 1 x-intercept, and it was real. So the way that we can use the discriminant, we notice that the actual value of the discriminant is not important. What is important is the sign. So whenever the b squared minus 4ac was less than 0, we had 2 imaginary answers. When b squared minus 4ac was greater than 0, we had 2 real solutions. And when it was equal to 0, we had 1 real solution. So this is something that we should have memorized. We should know when our discriminant is negative, we're not going to have any x-intercepts. When our discriminant's positive, it should cross the x-axis 2 times, and we'll have 2 real zeros. And when it's equal to 0, we're going to have a double 0, and it's going to bounce off the x-axis. So for these next problems, we need to look at the graph and determine whether the discriminant is greater than 0, less than 0, or equal to 0. So if we look at number 7 and we look at this graph, I notice it crosses the x-axis 2 times, so that means that b squared minus 4ac has to be greater than 0 because we have 2 intercepts. For number 8, if we look at this graph, it looks like it bounces off the x-axis, so that means that my discriminant should be equal to 0 because we said whenever the discriminant was 0, that's when we only had 1 x-intercept. Looking at number 9, this time it doesn't matter that our parabola is opening down. What matters is the fact that it never crosses the x-axis. So I'm going to say b squared minus 4ac is less than 0. And on number 10, I notice it crosses the x-axis twice. So I'm going to write b squared minus 4ac is greater than 0. So if we look at this, when b squared minus 4ac is greater than 0, we said we had 2 real solutions. When it was equal to 0, we had 1 real. And when it was less than 0, we had 2 imaginary solutions. So this is definitely what we need to know from using the discriminant. And now we're actually going to use the discriminant in a real life situation. John and Jamie went to Mexico to go bungee jumping. Now, everyone knows Mexico is a great place, but not necessarily a place that has the best checked safety regulations. Before John and Jamie jump, remember they're smart Honors Algebra 2 students here, they decide, hey, we better make sure that we are high enough to not hit the ground when we jump. They figure out that the elasticity of the bungee creates an equation of h equals t squared minus 9t plus k, where h is the height above the ground of John and Jamie at any time after jumping, and k is the initial height from which they are jumping. How can we use the discriminant of the quadratic formula to find how high John and Jamie must start to make sure they don't smack their heads on the ground? So we need to kind of think logically here. We need to think, do we want a positive discriminant, a negative discriminant, or a discriminant of 0? If ba squared minus 4ac was greater than 0, don't mind my lovely artwork here, John or Jamie would fall through and then come back through the cement. So that would definitely not be very good for them. My guess is they would probably die. Second situation, if it was just equal to 0, they would hit here and just land. So their full force would take them and land. I don't think that would be a very good situation either. So lastly, if b squared minus 4ac was less than 0, we can see that John or Jamie here is just chilling above the ground. They have not been injured at all. So we would definitely say that the discriminant would need to be negative. And we actually then could take this equation and go ahead and figure out what values would make this happen, but we're not going to do that today. So key things we learned about today, we learned about the quadratic formula, which we know works for every single quadratic function. We also learned about the discriminant and how we can use the discriminant to help us determine how many solutions we have and what type of solution we actually have.